More applications with exponential equations solved using logs. Tyler's bicycle has been decreasing in value by 5% per year. That's a decay function, sounds like. This year it was valued at 2,000. A, write an exponential equation for the value v of the bike t years from now. B, what will the bike be worth 10 years from now? C, when will the bike be half of this year's value? D, how long will it take the value to be halved again? So part A, the function, we start off with 2,000, that's the initial value. It's decaying at 5% per year, that's the decay rate. And the decay factor is 1 minus the decay rate, or 0.95. And if you forget the formula for that, all you have to do is realizing if it's dropped 5% each year, that means the new value is 95% of what it was. Okay, so we got our function. Then we want to know what's the worth of it in 10 years. V of 10, put the 10 up there, work that out with the calculator, and you get this amount right here, 1197. So it is dropping. All right, then part C, when will it be half of what it was? Well, it was 2,000. So when will it become 1,000? Half of 2,000. We have to solve for t. So divide both sides by 2,000 and reduce it. 1,000 over 2,000 is 1/2. So you have this. Now we're going to get this t down on the level of the equals, so we have to use log of both sides. The power rule says we can bring this t in the front. T log of this. Now isolate the t by dividing by log 0.95 on both sides. So that comes underneath here. So turning it around, t equals log of 1/2 over log of 0.95. Put it in the calculator, got a little cutoff there. 13.5 years, so we're going to round it up. It will take about 14 years for the bike to drop to half value. Then part D, when will it be halved again? Well, it halved, we took half, was 2,000 going to 1,000. So now we're going to go from 1,000 down to 500. It will be cut in half again. So we divide by 1,000 and get here. We reduce that down to 1/2. We have the same equation as we previously did. Take the log of both sides, solve for t the same way as before, and you get this exact value. And in the calculator it's the same amount, about 14 years. So the same amount of time to have again. That's all that's saying, is that the half-life is the same starting at any amount value for an exponential decay function.